Yes, feeders are allowed to be spliced on the load side of the main disconnecting means in a commercial building, but there are specific requirements that must be met. Firstly, the splice must be made in an approved junction box or enclosure. This ensures that the splice is contained within a safe and protected environment, preventing accidental contact and providing a degree of protection against environmental factors. Secondly, the splice must be made with an approved splicing device. There are numerous splicing devices available, and the choice of device will depend on factors such as the wire size, material, and the specific application. Approved splicing devices are designed to create a secure and reliable connection, minimizing the risk of loose connections, overheating, and other potential hazards. Thirdly, the wires must be properly sized and terminated. Correct wire sizing is essential to ensure that the conductors can safely carry the intended current without overheating. Proper termination involves securely attaching the wires to the splicing device, ensuring a low resistance connection. Fourthly, the splice must be protected from moisture and other environmental hazards. Moisture can corrode the conductors and the splicing device, leading to increased resistance and potential failure. In damp or wet locations, it is crucial to use splicing devices and enclosures that are specifically designed for wet locations. Additionally, the splice should be protected from other environmental hazards such as dust, chemicals, and physical damage. Fifthly, the splice must be accessible for inspection and maintenance. This means that the junction box or enclosure containing the splice must be readily accessible without requiring the removal of building finishes or other obstructions. Accessibility is important for routine inspections, troubleshooting, and any necessary repairs or replacements. It is important to note that splicing feeders in the load side of the main disconnecting means is not always the best practice. If possible, it is preferable to run the feeders in one continuous piece without any splices. Running continuous conductors eliminates the potential for failure at splice points and simplifies the installation. However, there may be situations where splicing is necessary, such as when the feeders are too long to run in one piece, or when there is an obstruction in the way. In such cases, it is essential to adhere to all applicable codes and standards to ensure a safe and reliable installation. The National Electrical Code, or NEC, provides detailed requirements for splicing conductors. It covers various aspects of splicing, including the types of splicing devices that are permitted, the methods of making splices, and the requirements for junction boxes and enclosures. Some relevant NEC articles include Article 110.14, which covers electrical connections. This section emphasizes the importance of making tight electrical connections between conductors and terminals. It requires that splicing devices be listed for the intended use, and that they be installed according to the manufacturer's instructions. Article 300.15 covers boxes, conduit bodies, and fittings where conductors are spliced or tapped. This section mandates the use of approved junction boxes or enclosures for all splices and terminations. It also specifies the required size of the box based on the number and size of the conductors within. Article 314 provides detailed requirements for outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. This article covers aspects such as box fill calculations, box mounting, and the use of covers. Article 392 addresses cable trays, which are often used to support feeder conductors in commercial buildings. This section outlines the requirements for cable tray installations, including the spacing and support of cables and the use of barriers to separate cables of different voltage levels. Article 408 covers switchboards and panel boards, which are commonly used to distribute power to various loads in a commercial building. This section addresses the requirements for the installation, wiring, and grounding of switchboards and panel boards. It also covers the overcurrent protection requirements for feeders and branch circuits. In addition to the NEC, local electrical codes may also have specific requirements for splicing feeders. It is important to check with the local authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and standards. Proper planning and coordination are essential for a successful feeder splicing installation. This includes carefully assessing the load requirements, selecting the appropriate conductors and splicing devices, and ensuring that the installation meets all applicable codes and standards. When splicing feeders, it is important to use the correct tools and techniques. This includes using a wire stripper to remove insulation without damaging the conductor, and using a crimping tool to properly crimp the splicing device. It is also important to ensure that the conductors are properly cleaned and prepared before making the splice. Regular inspections and maintenance are essential to ensure the continued reliability of spliced feeders. This includes visually inspecting the splices for any signs of damage or corrosion, and testing the connections to ensure that they are tight and secure. Any loose or corroded connections should be repaired or replaced immediately. Grounding is another critical aspect of feeder splicing installations. All metal enclosures and equipment must be properly grounded to provide a path for fault current to flow back to the source, minimizing the risk of electric shock. The grounding system must be installed in accordance with NEC Article 250, which covers grounding and bonding. Overcurrent protection is also essential to protect feeders from overload and short-circuit conditions. Overcurrent protection devices, such as circuit breakers or fuses, must be properly sized and installed to protect the conductors from damage. The overcurrent protection requirements for feeders are covered in NEC Article 240, which covers overcurrent protection. Voltage drop is another factor to consider when splicing feeders. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop in Article 215.2, which covers feeder calculations. Coordination between the electrician, engineer, and building owner is crucial for a successful feeder splicing installation. This includes clearly communicating the project requirements, addressing any concerns or questions, and ensuring that all parties are aware of their responsibilities. Documentation is also important for feeder splicing installations. This includes keeping records of the materials used, the splicing methods employed, and any inspections or tests that were performed. This documentation can be helpful for future troubleshooting or maintenance. Safety should always be the top priority when working with electricity. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves, and following all safety procedures. It is also important to energize the circuit before working on any electrical equipment. If you are unsure whether or not splicing feeders is allowed in your particular situation, it is best to consult with a qualified electrician. A qualified electrician will have the knowledge and experience to assess the specific circumstances and determine the best course of action. They can also ensure that the installation meets all applicable codes and standards. In summary, splicing feeders on the load side of the main disconnecting means in a commercial building is permitted under certain conditions. Firstly, the splice must be made in an approved junction box or enclosure. Secondly, the splice must be made with an approved splicing device. Thirdly, the wires must be properly sized and terminated. Fourthly, the splice must be protected from moisture and other environmental hazards. Fifthly, the splice must be accessible for inspection and maintenance. However, it is important to consider whether splicing is the best option for your specific situation. If possible, running continuous conductors is generally preferable. If splicing is necessary, be sure to consult with a qualified electrician and adhere to all applicable codes and standards. Always prioritize safety when working with electricity. Using the correct tools and techniques is essential for a safe and reliable feeder splicing installation. Regular inspections and maintenance are crucial for ensuring the continued performance of spliced feeders. By following these guidelines, you can ensure that your feeder splicing installation is safe, reliable, and code compliant. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for the most up-to-date requirements. Also, be aware of any specific requirements or guidelines that may be enforced by the local authority having jurisdiction. Careful planning, proper execution, and ongoing maintenance are key to a successful and long-lasting feeder splicing installation. Remember that working with electricity can be dangerous. If you are not qualified to perform electrical work, it is essential to hire a licensed electrician. A licensed electrician will have the necessary training and experience to safely and effectively complete the job. Don't take risks when it comes to electricity. Your safety and the safety of others depend on it.